guys, it's Miss Johnson and I'm here to bring you our notes for Unit 3 Notes 5. And today we are talking about negative exponents. So our learning target is I can simplify expressions with negative exponents. So up at the top we're going to talk about what the rule is or what we do with expressions when we have negative exponents. So the thing about negative exponents is we invert the location of the term with the negative exponent, and then we make the exponent positive. So we're going to flip its location and make the exponent positive. So if we look at an example there, let's say I have something like a to the negative fourth. Well, that means I have a to the negative fourth divided by 1. So what I need to do is I need to flip this whole power down to the bottom, and that makes my exponent positive. So now when I move it down below, it becomes a to the positive 4. Well, I got rid of everything that was up on the top, so all I have left now is a 1. Okay, so I moved it from the top to the bottom to make that power positive. Flip the location, make the power positive. But what we have to remember is we only flip the location of just the variable with the negative exponent. I don't want to move everything. I'm not going to move everything in the expression. I'm only going to flip the things that are raised to the negative power. So let's take a look at a few examples. In number 1, I have 4 times a to the negative second power. So in this question, this is 4 times a to the negative second over 1. And I need to take that a to the negative second, and I need to move it down below to the bottom. The 4 stays up on the top. The 4 stays where it is. So when I fix that, I have the 4 left over on the top. Sorry, that's kind of ugly to look at. 4 left over on the top, and when the a to the negative 2 power goes down to the bottom, it becomes a to the positive 2 power. At that point, I would simplify anything else that I could, but I don't have anything else here to simplify, so that's what I'm left with, 4 over a squared. In number 2, I have 1 over 3 times x to the negative first. Now, this x to the negative first is the only thing being raised to the negative power. The 3 is not. A lot of people automatically want to group the 3 in with the negative 1, but what that would look like is this. If it were 3x in parentheses, then raised to the negative first, then yes, that 3 would also be raised to the negative first power. But that's not what we have here. We don't have the parentheses, so it's just the x. So I take that x to the negative first power and I move it up, and what that leaves me with is an x to the positive first power on top and a 3 on the bottom. Now, technically you could write the 1 out in front if that helps you to remember that it was actually there in the first place, but that's not how you would see it on a multiple choice test. If you saw this on a multiple choice test, it would look like this. It would just be x over 3. We don't need to write x to the first, and we don't need to write the coefficient of 1, because those two things don't change our answer. Let's look at number 3. In number 3, I have 6a over b to the negative second. So b to the negative second can't stay like that. I'm not allowed to leave negative powers. So I flip it up to the top, and that leaves me with a positive power. So I have 6a that's already there. Then I have b to the second. And when I take everything out of the bottom, I'm left with a 1. Now again, dividing by 1 doesn't change our answer, so I don't actually need to write it like that. This is just 6ab squared. In number 4, I have 2 things that I need to flip. I have b to the negative third, that needs to come down to the bottom, and I have a to the negative second, that needs to come up to the top. So when I do that, and by the way, the 4 stays where it is. 4 is not being raised to any negative power, so I don't need to move it at all. So the 4 stays up on the top. Now with it, I have a to the positive 2 power, and moving down to the bottom is b to the positive 3 power. So 4a squared over b to the third. Now let's start to combine some of these things. We've seen a lot of these properties already. We've seen the fact that we need each base to appear only once. We've seen the fact that there are no power of powers, meaning no parentheses. Okay? Remember we said to get rid of those parentheses. We've also seen that we have to make fractions in simplest form, but then a new thing added to our list, a new item added to our list of simplified monomials is the fact that there are no negative exponents. We cannot leave negative exponents in the question or in the simplified expression. All right, let's flip it over and look at the back. We're going to put a bunch of things together now. So number 5, the first thing my eye is drawn towards is the fact that I have this b to the negative third that needs to come down, and I have d to the negative fifth that needs to move up. So when I take care of those two things, I now will have c squared on the top, which stays there because it was already positive. D to the negative fifth is now d to the positive fifth on the top, and b to the negative third is now b to the positive third on the bottom. I see c, d, b, nothing is there twice, there's no fraction to reduce, there's no parentheses. So now I'm good. In number 6, I notice this fraction out front. That's one thing that I see that I can fix. So 3 divided by 21, or I'm sorry, 3 over 21 is the same thing as if I take out the common factor of 3, 1 over 7. So I'm going to make that a 7. Then I have this a to the negative fourth that I know I need to move down below. I have this c to the negative fifth that I know I need to move up above. But then there's one other thing that I notice here. I notice that I have a b to the seventh on the top and a b to the seventh on the bottom. B to the seventh over b to the 7, 7 minus 7 is 0. And anything raised to the 0 power is just 1. Those two things are going to cancel out and go away. So now let's take a look at what I have. I still have this negative out front. Coming up to the top is now c to the fifth, c to the positive 5 power. Down in the bottom, I have that coefficient of 7. I also have the a squared that was already there. And in addition, I have the a to the fourth, which moved down from the top. So a to the negative fourth moved down, became a to the positive fourth. So I take a look at it again. I see c, I see 1/7, which can't be reduced anymore, but I see this a squared and a to the fourth. I'm only supposed to see each base one time. So I need to go ahead and fix those. So if I fix those, that gives me a c to the fifth on the top over 7, and then putting those together, a to the sixth. The whole thing is negative. That would go out front like that. Sorry, I kind of ran out of space. So I have negative c to the fifth over 7a to the sixth. Let's take a look at number 7. In number 7, lots of stuff that I can take care of. One thing that's really obvious and really easy is the fact that there's negatives out front. Now, you may be thinking, oh, I thought she said we had to move the negatives. These are negatives that are in front of a coefficient. That 3 is a coefficient. 3 is not a power. The q to the negative 2 power is something that needs to move. But this 3 is just a negative 3 coefficient. But we all know a negative divided by negative is a positive. So I can actually get rid of those and just make them positive, and they'll go away. Then let's take care of that fraction since we're right there. 3 over 12 is the same thing as 1 divided by 4. Now I'm going to start to look at my variables. I know that q to the negative 2 power needs to come down. I know that r to the third power needs to go up. And I know that s to the negative fifth power needs to come up. Now be careful when you're writing these. It's really easy for it to get really messy, and then it's hard to tell what we still have left. So I'm just going to rewrite what I see right now. That turned into a positive, that's fine. The 3 is gone, that's fine. That moved down, that's fine. So on the top I have an r, I have an s to the fourth, and I have an r to the positive third. That moved up from the bottom, and this s to the negative fifth moved up from the bottom, so now that's s to the positive fifth. All right, so that takes care of the top. On the bottom, I have this 4 coefficient out front, and then I also have a q that stayed there, and this q to the second moved down from the top. Okay, so I think I have everything moved that I need to, but now I got to put the like parts together, the variables that are in common, or the like bases, in other words. So for example, my r's. R to the first times r to the third is r to the fourth. So I have r to the fourth, then s to the fourth, these are also common. S to the fourth and s to the fifth, that's going to give me s to the ninth. And these are also in common on the bottom, so that 4 coefficient stays out front. Q to the first times q squared is q to the third. And that is my simplified expression. My fraction is reduced. I see each base only one time. There's no parentheses. There's no negative exponents. I'm good. Let's take a look at number 8. In number 8, the first thing I notice is this 24 over 6 that's out front. That's a coefficient. So 24 divided by 6, 24 on top is going to be a 4. The 6 is going to go away. Keep in mind that negative is still there. I only have a negative on the bottom, so I can't cancel it with the top. So now let's look at our variables. So x to the negative 2 power goes down below. X to the negative 3 power goes up above. Y to the negative second power goes up above. Z to the negative first power goes up above. Wow, a lot of stuff moving up here. So, goodness, let's look at what we have on the top. We have a lot on the top. There's a 4 coefficient. There's a y to the fourth that was already there. Now, I also have an x to the positive third. I have a y to the positive second, and I have a z to the positive first, which you don't necessarily need to write, but I will just for right now. On the bottom, I have that negative coefficient out front, which you can write a negative 1 if you want. And then I also have that x to the positive second that moved down. So now let's see what else we can simplify, because there's still kind of a lot going on in this problem. So on the top, I see y to the fourth and y to the second. That, when I put those together, is going to be y to the sixth. I also see some x's. I have an x to the third on the top, but also an x squared on the bottom. Now 3 minus 2 is 1. I have more on the top, so this is going to be x to the first, and these are going to go away. So there's nothing I can do with the z's. There's nothing else I can do with the coefficients. So now let's take a look at what we have. We have 4 times x times y to the sixth times z all over negative 1. Now, you can leave it like this. This is totally fine. I would not mark this wrong. However, if this were a multiple choice test, you don't actually have to write it divided by negative 1. You can take this negative and you can just push it off to the front of the 4. So negative 4 x, y to the sixth, z. Because technically negative 4 divided by, or I'm sorry, technically 4 divided by negative 1 is negative 4. All right, number 9. Okay, so now in number 9, I have a set of parentheses, meaning I have powers raised to a power, and I have things inside that I can check out to see if I can distribute, and I have this power outside that's a negative power. So let's talk about what that does to my fraction. So the first thing I'm going to do is simplify the inside. I notice that there's a d on the top and a d to the fifth on the bottom. So if I take care of that, this d to the fifth is going to be 4, because 4 minus 1 is, or I'm sorry, 5 minus 1 is 4. So the d on top goes away. I have d to the fourth left on the bottom. So let's rewrite that. I now have c squared over d to the fourth, all raised to the negative first power. So now let's talk about what that negative 1 power does on the outside of the parentheses. Well, it's going to make everything that's in the bottom come up and everything that's in the top go down, which in an essence just flips our fraction. We take the reciprocal of the fraction that's on the inside. Once we take the reciprocal, this power becomes positive power. So I flipped the fraction, made the power positive. If you need to write that down, go ahead and do that. Flip the fraction, make power positive. Then at that point, I would distribute my power inside if I needed to, but anything raised to the first power is just itself. So this is really just d to the fourth over c squared, and that's it. Let's try that again in number 10. So again, I have a power that's raised to a negative power. It's a power of power, but the outside power is negative. I'm going to start by simplifying the inside. I notice that I have an x squared over x. 2 minus this 1 that's here, 2 minus 1 is 1, and I have extras on top, so I'm going to have x to the first on top, and the x's on the bottom are going to go away. So now what that looks like is 3x over y to the fifth, all raised to the negative second power. Okay, so again, since I'm raising this to the negative 2 power, the stuff on the bottom needs to go up, the stuff on the top needs to go down. So in essence, I'm just flipping the fraction upside down. So now this is going to look like y to the 5th on the top over 3x on the bottom. And then that changes into a positive 2 power. Okay, now we're not quite done here because when I raise something to the positive 2 power, that means I have to actually take care of that. That means it's like I have two of these. It's like I have y to the 5th over 3x times another, times itself, times another y to the 5th over 3x. And what happens when I do that is it gives me y to the 10th over 9x squared. Okay, it's also the same thing as doing 5 times 2, which gives me 10, 3 squared, which gives me 9, and x to the 1 times 2, which is 2. So you get the same answers when you use that rule, or if you just write it out however many times you're multiplying and put them together. Okay, almost done here. So let's take a look at number 11. Now, I have some negative exponents to move on the inside and combine things together, and then I have a negative power on the outside to take care of. So I'm going to start on the inside, simplify the inside first. That will definitely help you. So if I move that x to the 3rd down, that's the same thing as saying y on top, x to the 3rd times x to the 5th, still raised to the negative 1st. I haven't fixed that. And we all know x to the 3rd and x to the 5th can go together, so that's really y over x to the 8th. And then x to the 8th, and that whole thing is raised to the negative 1st power. So now let's take care of that negative 1 power. This comes up, this goes down, this becomes positive, so that's x to the 8th over y, all raised to the 1st, which we know doesn't change our answer. That's just x to the 8th over y. Holy cow, last question. So number 12, I have a lot going on in number 12. Things to simplify, things to move, things to flip. Here we go. 4 over 6, that's a fraction outside, those are coefficients. So 4/6 reduced is going to be 2/3, 2 over 3. Then I have x to the 3rd on top, x on the bottom. 3 minus 1 is 2, so that goes away, and I'm left with x squared on the top. Then I have y to the negative 2 power, which moves up to the top. So that's going to give me, now let's take a look at what we have. We have 2 x to the 2nd y times another y to the 2nd. On the bottom, I have just a 3, but the whole thing is still raised to the negative 2 power. Holy cow. So now I am going to put my y's together because I can. That's 2x squared y to the 3rd. Y to the 1st times y squared is y to the 3rd over 3, all raised to the negative 2 power. Now, everything on top goes down, everything on the bottom goes up. This becomes positive. So that's 3 over 2x squared y to the 3rd, still raised to a power. It's raised to the 2nd power here, so I'm still not even quite finished. Now I need to multiply this thing by itself. So I'm just going to write out 2 of them because sometimes I think it's just easier to look at it twice. Even though you end up writing a little bit more, it's just easier if you've got the 2 right next to each other. So multiply it by itself, go straight across. 3 times 3 is 9. 2 times 2 is 4. X squared times x squared is x to the 4th. Y to the 3rd times y, oops, that was supposed to be a 3, sorry. Y to the 3rd times y to the 3rd is y to the 6th. Holy cow, that is our simplified expression. Okay, that's going to take us to the end of our notes video for Unit 3, Notes 5, Negative Exponents. Thanks for listening. Don't forget to check your note sheet off with Miss Johnson, and I will see you all tomorrow.